Hey everyone, this is Mrs. Williamson. I wanted to give you a quick overview of the rock cycle, things that you need to know definitely, and a little bit of information on that rock and mineral kit that you may have received in your supplies. So first of all, I have a diagram of the rock cycle right here, and we've been going over spheres in our Class Connect session. So this is a part of the geosphere that interacts up with the atmosphere. But your geosphere is made up of lots of different rock types. So you probably, this is going to be a review for a lot of you, I'm sure. But your rock types are divided up into igneous, sedimentary, and metamorphic. And this is a very generalized view of the rock cycle. I have my igneous rocks, which are made from heat that comes from deep in the earth. And igneous rocks can be changed into sedimentary rocks, or they can be changed into metamorphic rocks, but we're going to go down to sedimentary just for right now. The processes that can change one rock into a sedimentary rock would be weathering, which is the breakup of material, transportation, which is moving it from one place to another, and deposition, which is settling down and dropping it off. So those three processes make up your sedimentary rocks. When we're moving to metamorphic rocks, the two processes that you need to know to make a metamorphic rock would be pressure and heat. As we increase the pressure by burying it down deep into the earth, and we increase the heat by moving toward the center of the earth, we get metamorphic rocks, which are rocks that are changed. They were originally igneous rocks or sedimentary rocks, and they've been changed, metamorphosed. All right. Now, igneous rocks can be two different types. They can be either formed inside the earth or intrusive, or they can be formed outside of the earth or extrusive. So either way, they are formed through crystallization and melting. All right. So this is your very simple cycle, but as we know, cycles aren't always simple. So do we have to go in this linear pattern and just go from igneous to sedimentary to metamorphic and then back again? Nope, we sure don't. So let's look at a more complex version of this. This is really what the rock cycle looks like. All right, so again, I've got my three different types: igneous, sedimentary, and metamorphic. And here I've got kind of a choose your own adventure rock cycle, okay? So I'm gonna start with igneous. We're gonna say, okay, igneous is gonna turn into a sedimentary rock, okay? Transform through some processes. Those processes, again, same as the one before, weathering, transportation, and deposition. But what if the sedimentary rock was going to turn into an igneous rock? Can it do that? You bet it can. So what forms an igneous rock? Melting and crystallization. Okay, so can a sedimentary rock go through melting? Yes, absolutely. It can be buried inside the earth and melted and then recrystallized and become an igneous rock. All right, so then sedimentary. If it's going to become a metamorphic rock, what makes a metamorphic rock? Well, increased pressure and heat. So that's our basic path. But what if a metamorphic rock wants to get turned into a sedimentary? Yeah, it's thinking to itself, I'm going to turn into a sedimentary rock today. No, what if something happens to do that? Well, it goes through the same processes that would normally turn into a sedimentary rock. The metamorphic rock would be weathered or broken up, transported, and deposited. And then there you go. So now we have metamorphic. Can it become an igneous rock? Absolutely. So for a metamorphic rock to become an igneous rock, it has to go through the processes of melting and crystallization. all right? So it's going to melt and change this. It's not going to be metamorphic anymore. It's going to be this nice magma inside the earth, and then it's going to cool down and recrystallize into something totally different. But can an igneous rock become a metamorphic rock? Yes. How, you say? Well, the way we always become metamorphic rocks, through increased pressure and heat. It gets buried deep in the earth, or it gets subjected to some kind of pressure and heat. Maybe it's mountain building, maybe it's something else that it's right next to, but something drastic happens and it changes the composition of that rock. All right, so there's your basic overview of the rock cycle. Everything that you need to know for your test is right there. Which samples in your kit are minerals? All right, if you want to pause your video right here, you can take a look at these. I'm going to pull out just a few so that you can see some of them up close. Let's go ahead and grab number 7. Okay, number 7 is quartz. We're going to grab number 23, which is mica. We're going to grab number 24, which is graphite. And we're going to grab number 27, which is sulfur. Okay, so I picked some that I thought would be really cool to look at. So quartz is one that you probably have heard of before. All right, if you look at it up close, then you can see that it's almost translucent. You could almost see through some of these parts, and there aren't really any flat surfaces on here. There are lots of different forms of quartz. If you look at number 35, that's rose quartz, and it should be a little bit pink in comparison to your number 7. But it's the same thing. It's the same mineral. And check it out. I have this right here. This is amethyst. Okay, that's this February birthstone. And actually, it's quartz. But it has an extra element in the crystal structure that turns it purple. So quartz is all over the place. It's really neat, and it's used for lots of different things. Mica. This is probably the coolest thing that you have in your kit, okay? Take a look at it, take the pieces out. Don't worry if you break them, that's what it's there for. It's for you to play around with. But this mineral, it forms this naturally. You can peel these crystals, these are flat crystals of the mica, apart in sheets, all right? This is so cool. And mica is used in makeup. They powder it and they put it in your makeup to make it shiny. Graphite is number 24, and this is what is used in your pencils. So a lot of times people say, oh, I need more lead in my pencil. No, we're not using lead. You actually have this mineral. You have graphite. And if you take it, you actually can rub it on your paper and it should make a mark. See? Okay, so sulfur, number 27. Smell it. It should smell kind of like rotten eggs or like the heads of matches. That's exactly what it's used for, okay? This one is really easy to identify, and it's used for lots of stuff to do with fire burning and other kinds of things. So it's very unique, very identifiable. Other than that, you do also have halite in here, number 15. I forgot about that one. This is table salt. So in your salt shaker, on your table at dinner time. Yeah. So anyways, there you go. There are your minerals. All right. Clear that off and pause the video if you need to. Here are your rocks. Okay. And this is what I've done. I have labeled them igneous, sedimentary, and metamorphic. All right, so if it has a red line underneath it, it's igneous. If it has a green line underneath it, it's sedimentary. And if it has a blue line underneath it, it's metamorphic. Let's pause so that you can take a look at some of these. All right, now that you've taken a look at all of the different listings of rocks in your kit, let's actually take a few out and take a look at them up close. So we'll start with igneous. And so your number 6 is a granite. You'll be able to identify this because of the 3 different colors, unique colors that you see here in your rock. So those are different minerals, and most granites have a whole lot of pink in them, and that is the mineral feldspar, particularly potassium feldspar. So a lot of times true granites are going to have this kind of look that has large grains all over it, very chunky looking, and it's going to be pink in color. Another one that I want to look at is pumice, number 17. Okay, so take that one out, and you'll notice that it has holes all over it. This is a volcanic rock, and it is also igneous because it is formed through those volcanic processes from a lava, but all the holes are where gas was inside the lava and the gas escaped. So if you hold these two in your 2 hands, you'll notice that pumice is a whole lot lighter than your granite. Okay, and then I also have number 20, which is obsidian. So obsidian, you'll see, is very glassy. It's really shiny, and it's really sharp actually on the sides. It actually is a black volcanic glass. If you've ever seen The Shawshank Redemption, at the end when he's looking for that piece of black volcanic glass, all geologists will shout out obsidian. Yes, they know what it is. So look it up if you haven't, if you don't know what I'm talking about. This is formed through a volcanic process also, and it cools very, very quickly, so you can't even see the individual grains. So those are 3 igneous rocks. You'll notice you have others in here, but I chose those 3 as distinctive for a purpose. All right, so let's go on to sedimentary. All right, your number 5 is sandstone. All right, now if you pick up number 5, you notice this nice red color, and that's unique, but probably because it had some iron in it, but also if you feel it, it feels gritty. You can feel those grains, and that is distinctive of these sedimentary rocks. Sedimentary rocks are named mostly for their grain size. So because you can see these individual grains, if you look up close, you can actually see the individual sand grains, and you can feel it. That is a sandstone. We also have mudstone over here, number 31. That's not really one that I'm going to look at right now, but I am going to look at number 10, shale. Okay, so this one is very, very different from my sandstone in that it's smooth. And if you look at this up close, you should not be able to distinguish the grains apart at all. Okay, so this is usually a marine rock, so it was formed in ocean. Excuse me, I hit my document camera. An ocean environment. And it's very fine-grained material, and we'll see how this compares to some other rocks and what it could lead to some really interesting transformations in just a little bit. Last one I want to look at is limestone. That's number 18, okay? So at first glance, you might think that shale and limestone look very similar, but I want you to look very, very closely at limestone, okay? And I want to see if I can zoom in on this. Whoop. Can we zoom in? and focus. All right, this is gonna be tough, but my limestone has patterns in it. It has patterns. If I look at all the different parts of my limestone, and here, right inside, I should be able to see some shapes in my limestone. Now, what are those shapes? Well, they're the remains of creatures that lived a long time ago. These are actually fossils, okay? But a lot of times they are not intact enough, or they've been dissolved, or they've been transformed and compacted and recrystallized to the point where they have become part of the rock. So limestone is really unique because a lot of times it's made up of a lot of fossil material, particularly the shells of different organisms that lived a long time ago. So that is a sedimentary rock, but it's going to be compacted and deposited shells and other calcium and carbon-rich material. Okay, so we've got 6 up there now. What's left is our metamorphic rocks. All right, so these are rocks that have been changed from igneous or sedimentary to metamorphic. They've been metamorphosed, and so something has happened to them. First one I want you to look at is gneiss, okay? Gneiss, that is number 2. All right, so this is pronounced nice. You don't really pronounce the G. And this is a metamorphic rock that looks kind of similar to our granite, okay? Because it's chunky, all right? But the difference is in the minerals. If you look very closely, like I have been looking very closely at this one, and I don't know if you can see, let me see if I can focus in on this, but my sample at least has some garnets in it. That really dark color in there, those are actually garnets. And that's something that doesn't happen in igneous environments. It takes a lot of heat to make a garnet. So this is a rock that's been subjected to a lot of heat and a lot of pressure. And that's pretty neat that you have some of those there in your rock, okay? Next, number 4 is slate. So this one you can tell is really, really smooth on these sides, these planes. And then if you look closely at the cross section here, it almost looks like you could pull these sheets apart, like that mineral mica that we were doing before. And that's unique because there's a lot of mica inside this rock. Okay, so when this was metamorphosed, it began as something like this, like your shale, and then it was subjected to more heat and more pressure, and all those minerals were squished, and then it ended up like this because all of them lined up and made these nice rows. All right, so there's your slate. Number 9 is marble, and this one is just reflecting my light all over the place. Ooh, let's see if I can bring it down here, bring that light down. What do we say, guys? Oh, there we go. Okay, so marble can come in lots of different colors, but basically marble comes from limestone. So it's the same chemical composition, right? Normally it's calcium carbonate, CaCO3, and it's formed from all of those little shells at the bottom of the ocean, all little sea organism dead bodies piling up and then cementing together. And then if it's buried, it's subjected to intense heat and pressure, we get this beautiful rock, marble. Okay, and we use it for all sorts of stuff, but it is very fragile. It is very susceptible to acid, so acid rain will dissolve this away, and so we have to be very careful with that. Okay, so obviously we have a lot of others on here that are in your kit, but I wanted to give you an overview of these really fast so that we could apply them to our rock cycle and just kind of take a look at that quickly. So I'm going to bring this back up. Here's my rock cycle, and let's look at the one that has the picture. All right. So I'm going to start out with a an igneous rock. Let's start out with pumice. Okay. So we've got an igneous extrusive rock right here. It's going to go through some weathering and transportation and deposition. So let's say that pumice gets thrown out of the volcano, ejected, boom. All right. Then it gets broken up in the process of weathering into tiny little pieces. And those pieces are as small as sand. That sand is transported and deposited and becomes a sedimentary rock. All right. Now that sedimentary rock over time is subjected to intense pressure and heat because it gets buried down deep in the earth. Okay, so it gets buried down deep in the earth, and it's gonna recrystallize. All right, and get pressed together, and so all of that sandstone is going to turn into something totally different. Now, if this sandstone also had a little bit of mud in it or some other kinds of minerals, then maybe it would turn into something like this. Okay, I'm being a little bit out there, like I'm imagining some other minerals in my sandstone besides just quartz. Okay, so now we've got a metamorphic rock. How do metamorphic rocks become igneous? Well, they go through crystallization after melting. So we're going to melt this nice down. It's a nice rock right now, but we're going to melt it down, and then it's going to cool and recrystallize into a granite. All right. So we could do this with any one of the rocks that we just went through, but I wanted to give you a visual example of what all's going on. This granite, if it gets buried and subjected to intense heat and pressure, what's it going to do? It's going to become metamorphic. It's going to become a gneiss. All right, so this is basically it, guys. I hope that you learned something, and if you have any questions about rocks and minerals, please give me a shout. I'll put my information up here at the end, and I hope you enjoy the rest of your time here in environmental science. See ya.